Cloud computing is the on-demand delivery of compute power, database storage, and IT resources over the internet. Instead of maintaining physical hardware on premises, you access these resources through a cloud services platform with pay-as-you-go pricing. You pay only for the compute cycles you actually consume. Amazon EC2 provides raw virtual machines, but modern cloud infrastructure fragments into hundreds of smaller, specialized compute engines to handle highly specific tasks. Managing raw EC2 instances requires significant operational overhead. You are responsible for provisioning capacity, patching the operating system, and executing ongoing maintenance. To reduce that overhead, AWS provides a compute abstraction spectrum. Moving along this spectrum allows you to trade direct infrastructural control for automated scalability and maintenance. This creates several specialized alternatives: Docker containers, serverless functions, batch processing, and simplified virtual private servers. To master AWS architecture and to pass the Cloud Practitioner exam, you must memorize the strict boundary lines between these distinct compute services. Selecting the right service requires matching the precise level of abstraction to the technical limits of your workload. Docker is an open-source development platform used to deploy applications. Instead of virtualizing an entire machine, Docker packages applications into lightweight, isolated containers. Everything required to execute the software goes inside that container, including the code, runtimes, and all of its dependencies. Because the application is self-contained, it runs exactly the same regardless of where it is executed, from a developer's laptop to the AWS cloud. These containers can run on literally any operating system. To manage these containers at scale, AWS developed Amazon Elastic Container Service, or ECS. This is the native management layer for running Docker containers across a fleet of EC2 instances. If you need to run those same containers without provisioning or managing the underlying EC2 instances, you use AWS Fargate. Fargate operates as a serverless compute engine specifically built for containers. Containers abstract the operating system, ensuring that code behaves predictably from a local environment to production scale. The first major architectural boundary required for the exam is the time limit. AWS Lambda represents function as a service. It is purely serverless. You deploy your code, and it runs strictly on demand with zero server management. Lambda scales automatically from 0 to thousands of concurrent requests in response to traffic, requiring no human intervention. However, Lambda is built for short executions. A single function invocation is limited by time and can run for a maximum of 15 minutes. This constraint makes Lambda ideal for rapid, event-driven bursts and microservices. Certain workloads, such as financial modeling or video transcoding, often require continuous compute for hours or days. For these heavy workloads, AWS provides AWS Batch. This fully managed service enables you to efficiently run hundreds of thousands of computing jobs. A batch job is a computing task with a clear start and endpoint, rather than a continuous 24/7 web server. You define the job as a Docker image and schedule it. AWS Batch dynamically provisions the right amount of memory and compute, launching managed EC2 or cost-saving Spot instances to process the queue. Unlike Lambda, AWS Batch has no execution time limit. Time and queue scale dictate the choice. Sub-15-minute events belong to Lambda, while unbounded heavy data queues require Batch. The second major boundary is architectural complexity. Configuring separate EC2 instances, RDS databases, and load balancers can be overwhelming for users with very little cloud experience. For independent creators and small businesses, the primary goal is often rapid deployment rather than granular configuration. This breakdown shows how individual service costs can accumulate. Amazon Lightsail simplifies this by bundling virtual servers, storage, and databases into a single cohesive service. This bundling provides low, highly predictable flat-rate pricing compared to individual service meters. Users can launch full application stacks in seconds using pre-built templates for WordPress blogs, Magento stores, or Node.js environments. For the exam, remember that Lightsail intentionally lacks autoscaling. It also has limited integrations with the wider, more complex AWS ecosystem. Lightsail trades infinite scalability and deep customization for absolute cost predictability and operational simplicity. Passing the Cloud Practitioner exam requires applying these boundaries to specific scenarios. If a workload requires processing a heavy-duty, long-running data queue, the correct answer is always AWS Batch. If the workload is a short, sub-15-minute, event-driven execution, then the ideal solution is AWS Lambda. And if you require a simple, predictable environment without autoscaling, then the correct service is Amazon Lightsail. Cloud architecture is the discipline of mapping technical constraints to the precise level of abstraction a workload demands.